Today we are going to learn about mastering multi-stage Docker builds. You will gain the skills to optimize Docker images using multi-stage builds, focusing on reducing image size and enhancing security.
Welcome to our video on mastering multi-stage Docker builds. In this video, we will explore how to optimize Docker images using multi-stage builds. This process is crucial for reducing image size and enhancing security by effectively separating build and runtime dependencies. By the end of this session, you'll be equipped to create efficient, production-ready Docker images using advanced multi-stage build techniques. Let's dive into the world of Docker and learn how to streamline your container workflows with confidence.
Multi-stage builds in Docker are a powerful tool to create streamlined and efficient images. Essentially, they allow you to use multiple from statements within a single Dockerfile, each representing a different stage of the build process. The key advantage here is that you can selectively copy only the necessary artifacts from each stage into the final image, significantly reducing its size. This is especially beneficial in environments where minimizing the attack surface and improving performance are priorities. By separating the build environment from the runtime environment, we ensure that only the essential components make it to production. This not only enhances security but also simplifies the process of maintaining and updating images. Multi-stage builds are versatile and can be adapted for various use cases, such as compiling code, running tests, and packaging applications. Each stage can have its own base image and instructions, allowing for a tailored build process that meets specific project needs. Understanding the structure and flow of multi-stage builds is the first step in mastering Docker image optimization. Reducing the size of Docker images offers a multitude of benefits that can significantly impact the efficiency and security of your applications. Firstly, smaller images lead to faster deployment times. This speed is crucial in environments that require rapid scaling or frequent updates. Secondly, a reduced image size minimizes the attack surface. Fewer components mean fewer potential vulnerabilities, making your application more secure. Moreover, smaller images consume less storage space and bandwidth, which is particularly advantageous in cloud environments where such resources are often metered and can incur costs. Faster build and pull times are another direct result of reduced image sizes, leading to more efficient C/CD pipelines. Smaller images also translate to better resource utilization, allowing for more containers to run on the same hardware without compromising performance. All these benefits underscore the importance of mastering techniques like multi-stage builds to achieve optimal Docker image sizes.
Separating build dependencies from runtime dependencies is a core principle in creating optimized Docker images. The primary goal here is to ensure that only the necessary components are present in the final runtime environment. This separation is crucial for several reasons. Firstly, it reduces the overall image size by excluding build tools and libraries that are not required during runtime. This not only enhances performance but also minimizes the potential for security vulnerabilities arising from unused software. To achieve this separation, it's essential to clearly identify which dependencies are needed during the build phase and which are required at runtime. Tools such as package managers and dependency analyzers can aid in this process. By automating the identification and separation of dependencies, you can streamline the build process and ensure that your images remain lean and secure. Ultimately, this approach leads to more efficient and manageable Docker images, paving the way for smoother deployments and operations. Implementing multi-stage builds in a Dockerfile involves several key steps that enable you to leverage the full potential of Docker's capabilities. The process begins with writing a Dockerfile that includes multiple from instructions, each representing a different stage in the build process. Each stage can be based on a different base image, tailored to the specific needs of that stage. For instance, the initial stage might involve compiling source code using a build environment, while subsequent stages might focus on packaging the application for deployment. One of the critical features of multi-stage builds is the ability to selectively copy artifacts from one stage to another using the copy command. This capability allows you to precisely control which files and dependencies are included in the final runtime image. An example of a multi-stage build could start with a from Golang Alpine stage to compile a Go application, followed by a from scratch stage that only includes the compiled binary and necessary configuration files. By structuring your Dockerfile in this way, you can significantly reduce the image size and ensure that only the essential components are included in the final image. Efficient management of Docker files, including the use of comments and organized structure, is crucial for maintaining clarity and ease of updates. Optimizing build cache usage is a crucial aspect of enhancing the efficiency of Docker builds. Docker's build cache is a powerful feature that stores intermediate image layers, allowing subsequent builds to reuse these layers if they haven't changed. This can significantly reduce build times, as only the layers that have changed need to be rebuilt. To make the most of the build cache, it's essential to understand how Docker determines cache hits and misses. The order of instructions in your Dockerfile plays a pivotal role here. Placing less frequently changing instructions earlier in the file can maximize cache usage. Additionally, using multi-stage builds can further enhance cache efficiency by isolating stages that don't change often. It's also crucial to be aware of common pitfalls, such as cache busting, which can occur when using dynamically changing instructions like apt-get update. To avoid this, consider using specific versions of dependencies or leveraging Docker's ARG instruction to manage build time variables. By following these best practices, you can ensure that your Docker builds are not only faster but also more resource efficient, ultimately leading to a more streamlined development workflow.
Exploring real-world examples of multi-stage builds provides valuable insights into how these techniques can be effectively applied in various industries. For instance, in the financial sector, companies often leverage multi-stage builds to create streamlined, secure containers for processing transactions. By separating the build and runtime environments, they can ensure that sensitive data is protected and compliance requirements are met. In the tech industry, organizations use multi-stage builds to optimize their C/CD pipelines, enabling faster deployments and reducing downtime. A common challenge faced in these implementations is managing complex dependency chains. However, by adopting a modular approach and using tools like Docker Compose, teams can effectively manage dependencies and maintain flexibility. Another lesson learned from real-world projects is the importance of continuous monitoring and optimization. As applications evolve, so do their requirements, making it essential to regularly review and update Dockerfile configurations to maintain efficiency. By studying these examples, you'll gain a deeper understanding of how multi-stage builds can be tailored to meet the specific needs of your projects, ultimately leading to more robust and efficient deployments.
Adopting best practices for multi-stage builds is essential to fully harness their potential in creating efficient Docker images. One of the key practices is the effective use of build arguments, which allow you to customize builds without altering the Dockerfile itself. This flexibility is particularly useful in different deployment scenarios. Another important aspect is minimizing the number of layers in your Docker images. Each instruction in a Dockerfile adds a new layer, so consolidating commands where possible can lead to more efficient images. The proper use of copy and add instructions is also crucial. While copy is more efficient for adding files from the build context, add can be used for more complex operations, like extracting archives. Maintaining readability in your Dockerfile is vital, especially as projects grow in complexity. Using comments and organizing instructions logically can make your Dockerfile easier to understand and maintain. Finally, regularly updating base images ensures that your builds benefit from the latest security patches and performance improvements. By adhering to these best practices, you can create Docker images that are not only optimized for performance but also easy to manage and update. Troubleshooting common issues in Docker builds is an essential skill for ensuring smooth development workflows. One of the most frequent challenges is encountering build errors, which can arise from various sources, such as syntax mistakes in the Dockerfile or missing dependencies. To address these errors, it's crucial to carefully review the error messages provided in Docker build logs. These logs offer detailed insights into what went wrong and where, allowing you to pinpoint the source of the problem. Dependency conflicts are another common issue, often resulting from incompatible versions or missing libraries. A strategy to resolve these conflicts involves using specific versions of dependencies and employing tools like dependency managers to automate version control. Managing failed builds can be daunting, but by systematically isolating and testing individual stages, you can identify and address the root cause more efficiently. It's also beneficial to familiarize yourself with available resources and communities, such as Docker forums and GitHub repositories, where you can seek guidance and share experiences with other developers. By honing your troubleshooting skills, you'll be better equipped to handle the complexities of Docker builds and ensure your projects run smoothly. In conclusion, mastering multi-stage Docker builds is a transformative skill that can significantly enhance the efficiency and security of your Docker images. Throughout this video, we've explored the core components of multi-stage builds, the benefits of reducing image size, and the importance of separating build dependencies from runtime environments. By implementing best practices and optimizing build cache usage, you can streamline your build processes and achieve robust, production-ready images. We encourage you to apply these techniques to your projects and continue your learning journey through additional resources and community engagement. Thank you for joining us, and we look forward to seeing how you leverage multi-stage builds to optimize your Docker workflows.